Okay, so doing the example that's in your textbook, and the hint there was that sometimes for certain questions you have to use the by parts twice. And this is a great example. It's also going to help if you set it out nicely. Okay, so we want to start with e to the x sine x by dx, and again we look at it, it can't be done using substitution because one is not the derivative of the other. So we're going to try with parts. We go u, and then we want a u dashed, and then we want to choose one that's a derivative and one that we're going to integrate to get the original function. Previous questions we've said e to the x is the one that we integrate because it was easy, and that was when our first function was just x, because the derivative of x became 1. In this case, we're going to switch it up and we're going to make e to the x the function that we differentiate. And that means if we let v dashed be sine x, then the integral will be minus cos x. Okay, and once again we're going to follow the rule by doing the cross and then the through. So this now becomes, and again this is where I want to have our setting out nicely done. It does take a bit of room. So this becomes equals, okay, e to the x, so minus cos x e to the x, so minus e to the x cos x minus the integral of these two horizontally times together. So that's e to the x cos x, which is minus, so that now becomes a plus, by dx. So you can see we're sort of going, well, this is now repeating itself. So I've got minus e to the x cos x, and I've now got a function times a function. So guess what? We're going to do our integration by parts again. So again, we're going to say u equals e to the x, u dashed equals e to the x, and this time v dashed is cos x, and its integral is sine x. Okay, so now, let's rewrite that, look like a funny S then. So now we have the cross again, doop, doop. Okay, so that's going to be plus the integral of e to the x times sine x, so e to the x sine x minus the integral of e to the x times sine x. Now this is where it's important that you have written this nicely. So if we've got this here, we've got e to the integral of e to the x sine x by dx, right, equals all of this. Now what do you notice about this and this? You guessed it, they are the same. And what I can do is I'm going to get rid of this take integral by popping it on the other side, and I'm going to add, so this integral, all right, this integral here plus this one, that equals 2 lots of e to the x sine x by dx. And this is why I'm saying the setting out is important, because if you didn't sort of have it there and you just went, oh, equals, without writing your expression for what you're integrating, you would have lost this. You wouldn't have been able to see that you can add it onto the other side, that it's an actual equation. Okay, and this becomes e to the x. I'm going to pull out e to the x as a common factor, sine x minus cos x. Okay, and you know, like all of these, when I've integrated, there's a plus c plus c plus c. I'm just going to add it at the end. And so now, to get rid of that times 2, I'm going to divide by 2, or times by half. So therefore, the integral of sine x, which is what I was, e to the x sine x, which is what I'm after, is a half times e to the x sine x take cos x plus c. All right, you could plus c and so on. Okay, so it's a little bit different where you have to include your original statement there. Okay, so that was when we sort of got stuck into a loop, because you got this over and over again. Now, it's not always going to be that you will get stuck in a loop. it could just be that you just have to use your integration twice. So let's have a look at this one. Okay, so we've got x squared times e to the minus x. Okay, I'm going to start by going, u is going to be x squared. Okay, and therefore u dashed will be 2x. And then my v dashed will be e to the minus x, and therefore my integral will be minus e to the minus x. So when I'm doing this, we do the cross. We should be just into the roll of that by now. We get x squared times minus e to the x, so minus x squared e to the minus x, minus the integral of these two times together, so a negative, that's going to turn that into a plus, 2x e to the minus x by dx. So this means I am going to have to use my by parts again. So this time we'll go, let u equal 2x, u dashed equals 2, and I hope you realize now that's nice, because I haven't got a function here anymore. So I will, or should be able to integrate that. So that's e to the minus x. V equals minus e to the minus x, and in we go. So minus x squared e to the minus x. Right, we're going to do the cross multiplying there, so getting a minus 2x e to the minus x minus the integral of 2 times minus, so that becomes a plus. Right, a little bit repetitive. Okay, so we get minus x squared e to the minus x minus 2x e to the minus x. And now this is something that I can integrate, so that will just be minus 2 e to the minus x plus our friend c. Okay, these ones we should recognize that this is probably going to be the loop again. Okay, so let's get stuck in. I'm going to go integral e to the x cos x. Okay, and we're going to start with let u this time equal e to the x, u dash is e to the x, and then v dash is cos x, and the integral of that is sine x. Okay, so this is going to be e to the x sine x minus the integral e to the x times sine x, okay, by dx. But again, we've got a function times a function, so we're going to use our by parts a second time. We're going to say let u again equal e to the x, so u dashed is e to the x, and v dashed becomes sine x, and its integral function is minus cos x. So make sure that you're following those rules, because if you stuff up with a negative, oh, painful. Okay, and again, we're going with that. So we are saying minus all of this. I'm going to use brackets because it's late in the day and I don't want to stuff up. So that's going to be minus e to the x cos x minus the integral of e to the x. What are we? We're minusing e to the x, but negative cos x, so that now becomes a positive. Okay, yes, we've got the plus c's there. So again, I recognize that this is now a loop, because e to the x cos x, I've got another e to the x cos x here. So I'm going to do that little trickster where I'm going to get two things on one side, so cos x. Okay, let's tidy up. That's e to the x sine x. Minus and a minus become a plus. And then minus e to the x cos x. And we recognize that this one and this one are the same, so we're going to get them on the same side, which means we now have two lots of the integral of e to the x cos x. Lucky us. So e to the x sine x plus e. It looks like you're doing a whole lot of work here and you're just sort of rewriting things one after the other. Looks like induction, doesn't it? And here we go. Therefore, I wanted the integral of just e to the x cos x. So to get rid of that times 2, we are going to divide by 2. Okay, so that's going to be a half e to the x. Oh, actually, we'll pull out the e to the x like we did before, yeah? Because we've got them in both. So a half e to the x sine x plus cos x. And what do we don't forget? Plus c. So give the other two a go, but you'll see it sort of repeats. And again, setting out is crucial. Crucial. Okay?